Sudesh, how are you? Can you hear me?
Hi, Eric.
How you doing?
Good, thank you. How are you?
Good.
Nice to see you back.
You too. You too. It's good to be back. All right, let's get things set up here. We got a few people arriving. I had to get all set up again, and took a little longer than I thought. Also, my my mouse is all packed away, so that setup is kind of interesting right now. All right. Hey, Jonas, how are you?
Hey, Eric, how you doing?
Good. Good to see you.
Welcome back.
Thank you. Okay. And let's give it a couple minutes for everybody else to arrive. How the last couple of weeks been for you? Anybody have anything exciting going on? Nothing?
For me, nothing exciting. It's been busy.
Okay. I didn't have anything going on either. Kidding. It's been a very, very busy few weeks. Jason, how you doing?
Hey, what's up?
All right, excellent.
Doing good.
So I think Ellen is the only person left. We'll give her a minute to arrive. All right, so for anybody who's watching this live or in the future, it's been a few weeks since we actually were able to get together. I've had some work trips that kind of really occupied a lot of my time. Went to Boston, which was absolutely fantastic. It was everything I wanted to be. Really productive work-wise, but also it was really cool to see all the history. It was pretty amazing. I didn't put a whole lot of stuff out there on Twitter, but I got just tons of photographs and really enjoyed it a lot. Anybody here been to Boston before? Man.
No, I haven't been to Boston yet.
It is so worth the trip. It's an amazing town. Besides being full of history, it's also just a really great tourist town. It's very walkable. People are really friendly. The food's phenomenal. Architecture is great. Yeah, I loved everything about it. It was really great. All right, let me check in on Ellen real quick. Okay, no notice from her, so we'll go ahead and get going. We'll get her caught up to speed. Here's what I want to do tonight is I just want to do a bunch of small individual build this, build that, build the other thing with JavaScript. And the way I kind of want to do it is just one at a time, have you share your screen, and I'll give you something to code out. It'll be real simple. We're not building the Taj Mahal here or anything. But I'd like two things. One, I'll work with one of you directly, but two, I'd like each of you to also be trying to build the thing that we're showing on screen. And again, nothing complex. What I want to do, what I want to do is reinforce those 5 fundamental aspects of any computer program just over and over again with practical work in building out JavaScript code and JavaScript functions. So first thing I want to find out is just how far along did each of you get in terms of the tutorial? Alexandra, where did you get to?
I got to I think it was the anonymous functions, like under the JavaScript functions area.
Okay, good. Yeah, that whole concept is it's not that common in programming languages to have an anonymous function. In most programming languages, you have to explicitly name a function and then call it. So, okay, good. Sudesh? I can't hear you.
Sorry, I had limited times.
Yeah.
So I've gone through up to objects. So I covered I covered basics, variables, and data types, and gone through a whole object as
Okay,
well.
good. Okay, good. Well, this work we're going to do on functions will help you, and I won't call on you to be the one coding until later in the evening. But please do code along with everyone else.
Right.
Jonas?
Till the functions section.
Good. Okay. Excellent. And Jason?
I got down to the promises and async and await, but I mean, I don't know how much of this I really absorbed because a lot of
Yeah.
this is the first time I've been introduced to it. So I mean, I made it pretty far, but I don't really know how much of it stuck with me. You know what I mean?
Yeah, totally. Totally. Okay, good. Yeah, we'll work on async, I think, next week, right? So everyone else will have a chance to hopefully get caught up to that point. And I've got some ways to make that concept hopefully pretty real to you. But the best way to learn some of this stuff, honestly, is just to get your hands dirty and start building some stuff. So let's go ahead and start with that. And again, when Ellen gets caught up, or when she gets here, we'll get her caught up. And I'm going to build everything along the way as well. So let me go and let's everybody get our play app running, or run.js. Sorry, why did I call it? I have no idea why. So everybody get run.js starting, spun up. And Alexandra, I'm going to have you share your screen first. And we'll start building some stuff.
Okay. 1 second. Can you see that?
Hold on a second. Yes, absolutely. Okay, good. So let's just reinforce, first of all, the idea of an entrance point. I'd like you to just write a couple of comments. Doesn't matter what they say. Just these are comments. Put some comments into your file.
Okay.
Yeah, nothing on. Doesn't matter what they are, right? And then just make a simple function called simple function that returns the number 5. Takes no parameter, returns the number 5. I honestly don't care what it is. Good, excellent. All right, now, can anyone tell me what the entrance point is of this computer program? What line it's on?
Would that be line 3?
Anybody else have another thought? There's a trick question because I'm just mean that way. This program doesn't have any entrance point.
Yeah, because it had to have function call.
Yeah, we haven't called the function. We've declared one, right? So, and again, I just want to be really explicit about what I'm saying because from a certain point of view, I'm wrong and I'm the idiot. Okay. The fact is that in terms of, the CPU knowing where to start in executing code, yeah, when we get to line 1, it's going to start looking through there and figuring out what's going on. And when we get to line 3, the computer is actually going to do something. It's going to create this behavior called simple function. And it's going to set that behavior up in memory, ready and waiting to be called. So, like I said, from a certain point of view, I'm just being a bit of a jerk with it. But from a practical standpoint, I'm not. And part of the reason I'm stressing this is that one of the first things you'll look for when you're analyzing any one individual JavaScript file is just to scan through it and find where's the first point that the program is actually going to do something of significance, not read through some comments or set up functions that could be used later on, but actually start what we're going to call the main path of execution. And right now we have no instructions to be executed. So down below that function, why don't you put some instruction that can be executed? Let's just log something to the console, log, the word hello to the console. And you'll see that it actually executes. Notice, by the way, that until now, there wasn't any output on the right, because again, there weren't any instructions that we'd actually directed the CPU to execute in terms of a program. Oh, good, here's Ellen. Let's wait till her audio comes on. We'll get her caught up to speed. Hi, Ellen. You're on mute. Are you able to talk? If you're not able to, that's fine. Just go and throw something in the chat.
Okay, it's working.
Hi.
I couldn't unmute, do anything. Zoom
Yeah.
is just weird today.
Yeah, it was being troublesome for Jason, and over the last few weeks, Zoom's had some performance issues. Anyway, welcome.
Thank you.
Here's what we're doing. We're just going to spend much of tonight getting our hands dirty with JavaScript. And one by one, on a turnabout basis, I'll have each of you share your screen, and you'll be the one, coding in front of everyone. But I'd like everybody else to follow along. So if you can pull up run.js, just like Alexandra has. And you didn't miss very much at all. What we've done is first, I just had to throw a couple comments in, meaningless comments. And then she declared a function called simple function. You can see it on line 3, right?
Yeah.
And that's all we had on the screen. Go ahead and erase line 7 for a second, or comment it out, Alexandra, just comment it out. So essentially, this is all we had on the screen. And I asked the question of the class, can anyone tell me what the entrance point of this program is? And there were a couple different answers, but it was a trick question because from a practical standpoint, this program doesn't have an entrance point yet because we haven't told it to do anything. We've set a function called simple function that we could call on at some time, but we haven't called on it. So nothing's really been executed. You follow that?
Yeah.
Okay, good. And then we added line 7. Go ahead and uncomment that again and look on the right when she does. And suddenly we have some output. It's because we actually have an instruction that can be executed, right? And I know this is like dead simple, stuff, but I just want to reinforce its value to you in analyzing code. And again, because we're going to be dealing with a lot of functions we're going to build today, I want to stress something. Right now, within the context of this one specific JavaScript file, because all we have right now is this one file, we are looking at what's called the main path of execution, i.e. the program that executes our JavaScript will start at the top of the file, and it'll read through, and unless otherwise directed, it will just do one instruction after the other. That's the path of execution. And because this is the one that involves the first instruction, we're going to execute line 7. This is the main path of execution. We're going to have other paths of execution. Okay, good. So down below that, let's go ahead and deviate from the path of execution for the first time. Give us a line 8 or 9 or whatever. And let's log the output of calling simple function. Now, don't change anything.
Okay.
Can anyone? Yeah, don't change anything, because this is actually a really good learning experience. Can anyone, including you, Alexandra, tell me why we're getting the output we're getting on the right and what that output is?
I think it's saying that it's a function, so maybe you have to add the like the parentheses.
That's exactly right. Now, don't add them yet. Okay. I just want to clarify, this is yet again another really valuable thing when you're trying to read through someone else's code, or frankly, even your own code, if you haven't visited it in a while. Whenever you see parentheses after something, you know that we're calling a function. Or if it's like line 3, we're declaring it. But after we've declared a function, anytime you see parentheses after something, you know that's a function call. Without the parentheses, however, we're missing one crucial element. Remember in the 5 basic parts of a computer program, we talked about subprograms, right? And we said that subprograms can be called by other parts of your code, and they may or may not be given some information they need to do their job. We call the information we give it need to do its job what? What do we call that information?
Parameters.
Parameters. Good. Well, whether or not the function you're calling is being given parameters, you still need to include the parentheses where the parameters would go. So now on line 9, add those parentheses in. Okay, good. Now erase them. And you can see that the reason we're getting the output we are on the right is because we are being told to log just what is simple function. We're not saying execute simple function and then log whatever it returns. We're just saying log what simple function is. And what it is a function. That's why you see the italicized letter F. That means function in JavaScript, right? And then its name. So console.log is doing exactly what we told it to, because remember, computers are stupid. They're literal. They'll do what you said to do, not what you meant. Any questions on any of this?
I have a question.
Yeah.
Sometimes it like when you're doing something with like the DOM, like you're
Yeah.
like doing like a query selector, you don't always add the parentheses, I think, like when it's like the event listener, or you're doing like a click or something.
Yeah. Yeah. There, and by the way, one, I'm glad you noticed that when you saw it happen. And two, part of the reason I'm choosing very deliberately to teach you JavaScript outside of the browser is because when you then start using it in the browser and start to notice these odd behaviors that deviate from quote unquote standard JavaScript, you'll understand that they are in fact deviations. Quite often, what happens in various browser implementations, and remember, there's lots of companies that make browsers and they all implement handling JavaScript in their own unique way. What happens all too often with JavaScript implementations is they're trying to make the browser still comply with the specification for JavaScript and yet be forgiving enough of either sloppy code or simple mistakes. And so various creators of browsers will in fact deviate from the specification a little bit and say, well, based on the context, we pretty much know what the person meant. And so we'll interpret it that way. But that specific behavior, like any behavior in a computer program, has to be deliberately put in. And so, yeah, you will see oddnesses like that, Alexandra. And that's why we're learning it here, where it won't permit such things. So when you do see them, you go, oh, well, that's not what I expected. And then you can look it up and go, why is Opera doing it? And, you know, Opera is a browser, right? Why is Opera behaving that way? And is it only Opera? Do other browsers operate that way? Does that answer your question, Alexandra?
Yeah, it does. Thank you.
Yeah, absolutely. It's a good question. Okay. All right. So yeah, go ahead and correct this again to make it actually call the function. And I want to point something out just in terms of thinking like a computer. Line 9 deviates or steps off of the main path of execution how many times?
Would it be twice?
You know, I think so. But again, I'm a bit of a nerd. Okay. Explain your thinking, Alexandra.
I was thinking once when the console log function is called, and then also when like the simple function was called.
Yeah. Yeah, absolutely. It's kind of interesting. On line 7, it's the same thing. We're actually stepping away from the main path of execution just by calling this built-in function called log. We didn't make it, and it's so trivial and we use it so much in our programs, you never stop to consider that, well, wait a minute, we're actually not in the main path of execution anymore. We've stepped over into some function that I didn't even build called log. This function called log is attached to an object called the console, and we're going to pass control of the program over to that function called log. We're going to give it this string called hello, and it's going to issue a return, and that return is going to get displayed. Now, it's a trivial thing to go over, except when it isn't. When you're debugging a program and you're stepping through it literally one instruction at a time, you can sometimes get really hung up if you don't remember that, because you'll have to step through 2 instructions on line 7. Sorry, line 9. You'll have to step through, on line 7, you step through the 1. You go into the log, and then it does its job. But on line 8, you'll go into simple function and come back with the number 5. And then you'll step into log and come back and it'll show on the screen. Now, I actually don't know the answer to this because I haven't used run.js well enough. Does run.js let you debug stuff? Can you put a breakpoint and debug?
I don't know.
Anybody else know? Let's find out. I'm just going to Google it real quick. Run.js debug. Yeah, you can. How do you do it? All right. I'm using run.js. How do you do this? All right. Do me a favor, and just to the left of line 9, can you click there and see if it'll put a breakpoint? To the left of it.
Oh, yeah, no.
Okay, all right, that's fine. What happens if you right click on line 9? Anything? Okay, that's fine. We'll get into debugging later on. It's just something to reinforce. We're going to add complexity on as we go. All right, good. So now let's start. And again, I want everybody to follow along. Let's go ahead and switch over to Sudesh. Can you go to, I'm sorry, to Jason. Can you share your screen?
Sure.
All right, good. I want you, and I want everyone to do this. I'd like you to make a function down below the console.log that calculates the square root of whatever integer it receives and returns the square root. And if you're stuck, just ask me. That's what we're here for. Are you talking?
Oh, I thought you could hear me. Yeah, I don't know how to do that.
That's fine. We'll lead you through it right now. Okay, good. So we'll start with functions that you actually give a name to. So type function, then after function, take away those the parentheses, and just think of a name for this function. What do you want it to be called?
Square root.
Who said that?
Units.
Okay, let me just work with Jason directly, and then you follow along. Okay. Okay, good. So we'll call it square root. Okay. Now remember that we're going to call on this thing. We're going to be in the main path of execution, and you're going to call on this thing when you need a specific chunk of work done. In this case, we want to be able to calculate square roots.
Okay.
So these functions, again, a subprogram. If you think about the 5 fundamental elements we've all been learning, you may or may not need to give it some information in order to do its job. Now, in this case, do you think you'll need to give it information to do its job?
Yes.
Good. So put the information you need to do its job, i.e. the parameters, inside the parentheses. Now, this next part's pretty important. I'd like everybody to pay attention to this next concept. whatever the name is that Jason chooses to give this parameter, that name, and more importantly, the value that it holds when we actually do use this function, only exists inside the function. It's called scope. We're going to spend a lot of time on it. But for now, Jason, just go and think of like, while this function is running and it's working with information that was given to it, what do you want to call the information it was given?
Well, I don't know. Can I call it anything?
You absolutely can.
Okay. Let's see. So we're just going to take the square root of something that it receives. So I guess number.
Good. Perfect. All right. Now inside the curly brackets, let's do whatever math you want to do and then return the answer.
Okay. So it's, how do you do the square root? I don't know how to do that.
Just something times itself.
Yeah. So number. That'd be it.
I can't see it. Oh, sorry. Move your, thank you. Yes, although what's happening here is you're directing an operation to occur, but you're not doing anything with the result. There's only a couple of things you can do.
Mhm.
One is you could create a variable and give it a value equal to whatever this math is. Try that one.
Okay, so we'll do we clear the variable inside of the function?
Yes, absolutely. All the works can be done inside this function.
Okay.
You can call the variable whatever you want.
Yeah. Well, we can't do a number.
Why can't you call it number?
Well, I guess we can.
No, you were right. You can't.
Oh, well, we've made that the this.
The parameter coming in. Exactly.
Yeah. Let just name it whatever.
No, Jason, this is actually a really important learning thing. What are the things you're thinking of as factors involved in what to name it? Let us inside your head.
Well,
oh god, it's scary in there. Okay.
It is. You trust me. You don't want to know. No. I'm thinking of, oh, are we going to have to refer to this like later on? You know what I mean? Like I'm thinking of, if we write a program, this has to be like the name of it that we're going to refer to. So it needs to be like a good name.
Good. Excellent. So totally valid thought. One thing to remember is that whatever variable you declare here only exists inside this function when the function is running.
Okay.
So in the rest of the program, it means nothing.
Okay. So can we do like number value?
Sure.
Okay. Goals.
And yeah, what value do you want to give that variable called number value?
Well, I don't know. Number value times itself. That doesn't make sense though.
It doesn't. It doesn't. So let's just think about this for a second. If you look at the screen right now on line 12, we've done one thing. We have created a variable called number value, which sets aside some space in RAM. And that space has a name. The name is number value. That's called declaring a variable. That's what you did so far on line 12, right? What's missing is assigning a value to store in that memory location. What value do we want to store in that memory location?
The number.
That we got passed in?
Right. Yeah. That we That's the, yeah.
Okay, good. Tell me your thought process. What are you going to do with that once you, let's say we pass in the number 5. And then on line 12, you create this variable called number value. And then you assign it a value of 5 because that's what got passed in.
Okay.
What are you now going to do with the variable called number value?
Get the square root of it.
Okay, good. Go ahead and write it that way. By the way, I'd like everybody to follow along, even if you have different ideas about how to do this. There's a learning moment in everything that happens here. So go ahead and give it the value of whatever got passed in, the parameter. Make it equal to number is what you're thinking of, right?
Yeah.
Go to type out
suppose.
number. Yeah. Good. Hit a
Okay.
semicolon. All right. So now we have a variable you created at line 12. And that variable has what name?
Number value.
Good. And you also assigned it a value. What value does that variable have?
Number.
Okay, good. And I want you all to get used to using terminology. It has the value of whatever the value of the parameter called number is. Good. So yeah, so again, in our example, if we passed in the value 5, then number came in being equal to 5, and then we use that to create a variable called number value. You good? Okay,
I'm
good.
following.
Good. So what would you want to do next?
Well, I don't know right off the top of my head.
Okay, so this is how I kind of solve these things when I'm not quite sure. I do know I want to return something. That whoever called upon this function had need of my services. I'm this lowly function called square root. And the main path of execution or some other code called on me to do a job. And in this specific instance, I'm going to have to give them back something. I'm going to have to give them back an answer, right? So sometimes what I do is I make a variable just for what I'm going to return, and then I write down to return it. So hit enter a couple of times, and let's just make a variable called result. And you can initialize it to 0. Let equal 0. Who gives a crap right now? I don't care. This is just to help me think with what I'm doing here. And then give me a semicolon. And now you want to return that. So hit enter and return that variable. Do you follow the logic there? Like, no, we're going to build backwards here. We know that when someone calls on this function, we're going to return something. And we've decided to have a variable called result, and that is what we're going to return.
Okay.
So never mind all the stuff in the middle on lines 12 through 15. Let's make this concrete. If someone called this function and passed in a 5, that's the value of the variable called number on line 11. And so when passed in a 5, when we get down to line 16 and return this variable called result, what should result be equal to?
The square root of 5.
Okay, let's make it easier because I'm being an idiot. 9. They passed in 9.
Okay.
I was actually going backwards. I was squaring it. Okay, you know what? To make this a little more, I just realized I am being an idiot. We want to square it, not to get the square root.
Oh, okay.
So change the name on line 11 to something
That
you think will make
totally
more
threw
sense.
me off.
Yeah, that's totally on me.
Okay.
Okay, good.
Number,
Square the number. Excellent. Okay, so to get back before I confused the issue, if we pass in 5 as the value of the parameter called number, then what should result be?
25.
Okay, good. So how do you get there? How do you do the math to make result be the right value?
5 times 5, so it would be number times number, essentially.
Good. Okay. How would you like to write that? in terms of
Well,
JavaScript.
How would I like to write it out? I would just put number. I would just do. I don't know if that's correct or not. I would have to look up for the syntax or whatever, but it would be something like that.
Good. Now, again, what's super important about line 13 is you're not doing anything
Right.
with that. You're just doing some math, but it just gets done and then disappears.
Like, look, we would do it to a variable, like let some variable equal number times number or something.
Good. Write it that way. Write it
Yeah.
that way.
Wait. Would we do that on a different line?
Here, let's think through and see if we can answer this. Okay. Let's look at line 12. What does the word let do?
Sounds it as a variable.
In what?
It lets this equal like be a variable.
Yeah, it's the instruction in JavaScript to declare a variable.
Right.
That's the terminology, is declare. Okay. Now, once a variable is declared, do you need to declare it again?
No.
Right. You have set aside that spot in memory. In this case, that spot is called number value.
Mm.
And in our instance, on line 12, we've actually put a value in that little space in memory. We put the value that was passed in. Now, what do you want to do? You want to do some math, right?
Mhm.
Okay. So you can change the value stored in that spot in memory. And the way all you need to do is assign a new value. On line 12, what part of line 12 actually assigned the value to the variable?
The number.
Line 12. Good. So line number is the value. What
Mhm.
part assigned that?
The let number value.
Yeah, which character or characters on line 12 caused an assignment to happen?
Let.
Nope. That's what
Or
caused a
equals, I'm sorry.
declaration to happen.
Yeah, equals. My bad.
Exactly. The equal sign is an assignment operator, is what it's called. And when you use it, whatever's to the right is used as a value and assigned to whatever's on the left. So we want to assign a value to the variable, called number value. We've already assigned it one value. Do we
Right.
want to change that value? Where do you want to put your answer is my question.
Result.
Good, excellent. Okay. So how could you do that?
We do let result equal number times number.
Good. Now, if you write it again on line 13, and you've also got it on line 15, now you got to have a problem because you're going to declare the variable twice.
Yeah.
So where can you put it?
So on 15.
Yeah, go for it.
Mm.
Awesome. All right, good. So let's see whether this works. How can you test this function? How can you see what happens when it runs?
Oh, we would have to call it.
Good. Go ahead and do that. How would you do it?
Do we want to? Yeah. We're just going to do it to the console.
Sure, go for it.
We'll have to input a number somewhere.
Yeah, where would you put it?
Yeah, I don't know.
Right there in the parentheses.
Yeah.
Look at that bad boy. It worked. Now, we're going to change the code in there a little bit. We're going to do what's called refactoring, and I'll help lead you through it. But I just want to point something out, and I want to point this out to everyone. Jason was given an assignment and he created code that did the job. That is the responsibility of a junior developer. Someone more seasoned or experienced can come along and refine it. But it's much easier for the experienced developer to come along and do that when there's an already working installation in process, in existence, an already working function. So Jason, from that point of view, did an excellent job as an entry-level developer. And this will carry all the way through as a theme through this whole class. You're not going to be expected to write, perfect, awesome, most efficient code. Oh my God, people should bow down to you because you're the God of all developers when you hit the job. You should be able to figure out how to write something that works. And then maybe step back a little bit and see if you can improve on it. Ask for advice from someone more experienced and see if they can show you ways to improve upon it. But get it working first. Does that make sense? Okay, good. Now, let's talk about a couple ways that the code inside there could be improved. And I want to stress something. We're not saying you can fix something because your code works. Could be improved. There's usually a couple things you could improve about a function. And they involve how much time will be taken up by it running and how much memory space will be taken up by its running. Let's look at that second one. On line 11, we're passing in a parameter. We've given it the name number, correct? Where is that number in terms of the internals of the computer? When we call on the function squared number, where is it?
Number is a local.
Jonas, hold on. You're going to get your
Sorry.
chance. I'm just going to work this through with him, okay?
Sorry.
It's all right.
Okay. Where
here-
is it?
Yeah,
In memory.
good. It's in RAM, okay? It's in a spot in memory. Does that spot have a name? Designator, a unique identifier.
Sure.
What is it?
I don't know.
It's just the number. It's just the word number.
Yeah. Okay.
Good. So another thing to know is that on line 11, when we declared this function, you should know that when the function gets called, even though you haven't used the control word let or the control word const or the control word var, you're still creating a spot in memory with a name and putting a value in that spot. That's still occurring. Make sense?
Mhm.
Good. So let's start from that knowledge that right now, the moment we actually call the function, because on line 20, we're finally calling the function that you made. When we call the function and pass in the number 4, the computer will actually put a spot in RAM called number and give it a value of 4. Go up to line 11. That's what happened when we called the function.
Mhm.
So we have a named spot in memory. We know what the name is. It's number. We have the value in there. So what happens on line 12 in RAM? What do we do in RAM on line 12?
We're calling on that same number again
Well, that's what
by
happens at the
assigning
end
a
of it.
variable to it. Well, we're assigning a variable to that number.
Let's look at the terminology there. There's 2 operations here.
Mhm.
The first is declaring a variable. The second is assigning it a value.
Right.
Which portion of line 12 is declaring a variable?
The let number value.
Good. So what happens in RAM during that portion of line 12?
There's a variable in RAM that it stores number value.
Well, it doesn't store a number value. It
No,
just
just
gives
the
it a
variable.
name. Yeah. We give it, there's a spot in RAM with a name. The second part is called, so that's called declaring the variable. The second part is assignment of a value. And that's that part that you highlighted right there, correct?
Yeah,
Good.
and we don't
So-
really need this at all. Do we?
I want to give you a high five through the computer. That's exactly it. We don't need it, do we? Tell me why. Why don't we need it?
We're not doing anything with this. This number value, we're just not doing anything with it. We're assigning a variable for no reason.
Right. More importantly, we already have a named spot in memory
for
that has the
number.
data we want.
Yeah,
Go and delete it. And look at your output on line 18 on the right.
Mhm.
Still works. Okay, good. Now, let's think about the CPU and all the hoops we're making the CPU go through in this function. We're on line 13 telling the CPU to do two things. I want you to tell me what the two things are on line 13.
we're assigning result as a variable.
No,
Or
wrong
no,
terminology.
I'm sorry, we're declaring result as a variable,
Good.
assigning it number times number.
Yeah, we're assigning the value resulting from doing the math operation.
Yeah.
Exactly. Good. Okay. So what if there were a way to return the answer we want without making a new variable and taking
Right.
up space in memory?
Right, we can just do.
Yeah. Good. Now I want to point something out. There was nothing wrong, in air quotes, about the way you did it before. There wasn't anything wrong. It's just simply a matter of efficiency. And I'm really glad that you actually did it this way, legitimately. Because when you are advancing in your skill as an engineer, one of the primary things you look at in analyzing how good code is efficient use of the space in the computer, the memory space. Now, from a certain point of view, you might think, well, memory is so cheap nowadays. We're not in the 1970s, Eric. We're not building with this tiny little four kilobytes of RAM or some crap like that, right? But when you're operating at the scale required by a lot of modern businesses, if you use memory unnecessarily, one, you're costing the company a lot of money, and two, you're slowing down the operation because it actually takes real time. However minuscule it might be in microseconds. It takes real time to choose a chunk of available RAM and give it a designator and then assign a value to it. That takes real time. It's not like it just happens in no time. So the code, as you've written it now, is just simply more efficient. But it does the same end result. Anybody have any comments about that or thoughts? Okay, good. Go ahead. Was someone else going to say something?
I
Okay.
think this is called refactoring the code.
Exactly. That's the exact term for what we did is we refactored the code. It has a different factor or shape or appearance or form. It's called refactoring the code. So let's review here, okay? And again, I'm going to use the precise terminology because I want you to be comfortable with the terminology because it indicates what's happening in the CPU and in memory. When the JavaScript interpreter first hits line 11, it creates a behavior stored in RAM called square number, but doesn't do anything with it because it hasn't been told to. When the interpreter reaches line 17, it's now told to do something with that behavior called squared number. Specifically, the CPU is, or the interpreter is given the number 4 and asked to call the behavior called squared number and receive whatever it returns and then log it onto the console. So then the path of execution transfers from the main path down inside the function called squared number. Squared number receives a parameter called number, whose value right now happens to be the number 4. Inside the function now that it's being called, we first do 2 things on line 13. We do the math operation of multiplying whatever parameter was passed in by itself, and then we take whatever result there was and we return that to the code that called upon the function squared number. In this specific exact case, the code that called upon the function squared number is the function called log that is part of the object called console. Now, I know that especially if you've been studying JavaScript even for a little while, you can read this and figure all that out. But I need you to know the terminology involved. Any questions about the terminology I just used? Okay, good, excellent. All right, let's go ahead and switch. Ellen, are you able to share your screen? Good job, by the way.
Yes.
Jason. I want to validate you, by the way, Jason. It's never fun to code in front of everybody.
Oh no, my brain's kind of fried too after working 10 hours. So
Oh yeah,
being on the spot and my brain being a little bit fried, and
always fun.
you have to get used to me.
Totally fine. Okay, good. So the thing I want to add in terms of complexity right now is we talked in very basic terms about this path of execution, and I've kind of simplified it and said that the main path of execution can call on a function, and then when the function is done, control is passed back to the main path of execution. But the fact is that a function can be called by another function or within another function. So let's do an example of that. What I want you to do is we're going to build. Anybody here not heard of what's called a Rube Goldberg machine? Has anybody never heard of a Rube Goldberg machine?
I think I have.
Never.
Okay, so let me here. I'm gonna take over and just show you this. Okay, I'm gonna share my screen for a second. I'm gonna take over. We'll come back to you. A Rube Goldberg machine is a machine that includes a tremendous number of steps to accomplish a simple thing. So here, it looks like the clock vibrates because the alarm went off. This object is right near the edge of the table, so it falls into this wheel. The wheel spins counterclockwise, knocks over the cup. Little balls in the cup fall into the bucket. The bucket pulls down on the scissors. The scissors then cut the string, which lets the boot drop, which staples the paper. So this is a machine to staple papers. I just love these things. They're so stupid, but they're awesome. So that's a Rube Goldberg machine. and Rube Goldberg was an actual person. So that's enough of that. I just didn't want to use the term. We're going to do something like that. I'm going to stop sharing. Go to share your screen again, Ellen. And Ellen, what I'd like you to try to build is a function that will first calculate the square root of, it will get the square root of something, and then it'll square it and then return the answer. So it should return whatever's passed in. First, it'll get a square root, then it'll square the answer, and then it returns that answer, and then you get back what you passed in. Just for the heck of it to build something. So first, handle the square root part of it. And this is one where
I have no idea after
it's totally
how
fine.
to
Okay,
calculate
here
square
we
root.
can, here we can actually cheat a little bit. So go to make a function called square root and pass in some kind of parameter, whatever you want to call it. Awesome. Okay, good. Now, this exists, I believe, inside JavaScript. Go and Google it and just say square root in
Oh, yeah.
JavaScript.
Math.sqrt.
SQR, I think.
If you're not sure, just look it up. And nobody say anything as I lead her through this. Just each time one of you is sharing, it's my opportunity to work directly with you and learn a bit about how you think.
Googling right now the JavaScript math to make sure if it's, yeah, it's SQRT,
Okay, good.
like Jonas said.
And passing them. Okay, good.
All
All right.
Oops, that was a cat. I'm just checking if it's working. Yeah, it looks like it works.
Good. Now, this little playground is rather forgiving. Okay, there's a couple of bad habits I want to kill right now. How do you put line numbers? Go to the top of the screen and go to all the way to the top. You should see. I can't see them, but under options or something like that, or preferences.
Oh,
It's
yeah,
file
Yeah,
preferences.
preferences.
Line number. Okay.
Awesome. So let's talk about a couple of things. On line 16, you have a space between the name of your function and the first parentheses.
Mhm.
Good. It will work, but it will be extremely jarring to anybody reading it. Good. Same thing on line 20. When you're calling the log function. Yeah, okay, good. All right, now, second thing, this works, and that was really good to look up the right syntax. The function that you're going to create, it'll get the square root, and then it'll square the square root. And then you'll return whatever that answer is. So let's think this through. Your function,
So
go ahead.
I was thinking to create a variable result,
Mm-hmm.
and then have it here. That's no, that is the root. Oh, I need to declare root. So, and now can I do another function called? So I need to square it again. Yeah, square. And then I'm gonna pass square root square root as a parameter, and then my result will be to return square times square root. I'm not sure.
Okay, good. So we're on the right track here. Let's talk about a couple of things. First, I want to examine the syntax that you've used on line 19 and then 23. So let's just talk about that spot for a second.
19 here.
Yeah, so let's look at 19 and line 23. There's something about the syntax that you're using there that I want to just explore. Okay. Now you have created those variables, result and root. You made them on line 15 and 16, correct?
Mhm.
So you declared the variables. But let's look a little more precisely at what you're telling the computer to do on line 19. You're taking the variable root. Now, so far, the variable root hasn't been assigned a value, right?
No, yeah.
Okay,
I mean, that would be that.
right. Now, you are in this instruction on line 19, kind of like telling the computer, you know that variable called root? I want it to assign you a value. I don't know the value yet. We're going to know what the value is by performing what's after the equals symbol. What's after the equals symbol?
It's the computation of the square root.
What's after the equal symbol is the word return. What does return do in a JavaScript function?
Oh, it's square. It's oh, shoot, how is that? It store the result of that.
It does what?
It stores the
No,
result.
what return does is it exits the function and gives back whatever is after the word return to whoever called the function. As an example, let's look up at line 10, okay? When the interpreter, the JavaScript interpreter, reaches line 10, here's very precisely what happens. There's two operations that happen. The first one is we do the math of number times number and get a result, right? And then we leave the function. We exit the function called squared number. We're gone. And we take that result we got and we give it to whatever code called on the function squared number. You can see that happening on line 12. On line 12, we're calling the function squared number. So to be very precise, the code that calls the function squared number is the log function. The log function calls the squared number function. You following so far?
Mm-hmm.
So now let's say we're inside the squared number function and we're on line 10. And on line 10, we do the math of 2 times 2 and we get the answer 4. And then we return, which means we leave the squared number function and we bring that result of 4 with us. And we give it to whatever code called squared number function. And what code is it that called the squared number function?
That line 10.
That isn't calling a function. That's just doing math. Line 12, let's examine line 12 very precisely. Look at the first 2 words, console.log, and take that space away if you don't mind. Okay, good. We call console.log. Now, what does console.log do?
Well, it's gonna make showing that.
Okay, good. Now I'm asking in a generic sense. What does console.log do? It's a function that does what?
It log the function.
It prints output to a console. That's all console.log does, is it prints output to a console. So do me a favor and look at line 5. Take away the space mark, if you don't mind. the space mark, the space. All that's happening here is we've got a function called log that's built into JavaScript. We're calling that function. And what that function does is whatever's inside the parameters gets printed out to the console. Right? Okay, good. So what happens on line 12 is very similar. We're going to add a little bit of complexity. It's console.log, which means we're going to print something out to the console. But the thing that we're going to print to the console doesn't exist yet. The thing we're going to print to the console won't exist until the function called squared number does its job and gives us something back. You follow that? Okay. So the reason that we even arrive at calling on this squared number function is because the log function that we're trying to do tells the squared number function to execute. The log function looks at the parentheses that it has. Show me the parentheses for the log function. Perfect. It looks inside there and it says, okay, whatever's inside here is the information I need. And unlike on line 5, what it finds is instead of information, it finds a function that it needs to call. It's like, really? You're going to make me do work? Okay. All right. I will, being the log function, the log function, I'll call this squared number function and I'll even give it this number of 2. But now you made me wait. I've got to sit here and wait. I've got to wait for the squared number function to get done and give me some information back. When it's done, now I will have something that I can print to a console. You following? Good, excellent. Don't start changing everything yet. I know you're jumping through and you're realizing some things, right? Good.
Yeah.
Just go with me one step at a time. Okay. So the reason, go to make line 20 go back to the way it was. Good. You tell me why you changed that. What was wrong about that?
I don't need a variable here in order to finish that second part.
Good. That's part of it. You're absolutely right. You don't need a variable. But the other part of what's not going to quite work about line 19 is this. If you look at 19, it's got an assignment operator. The equals is an assignment operator. What that means very precisely is to the right of the assignment operator is meant to be some sort of a value. And to the left is the variable that will be assigned that value on the right. So what's to the right of the equal sign?
Well, right now it's not a value,
It's a command to exit the
to do something.
Yeah, to leave the function and return something. So it doesn't result in a value that we can assign to the variable called root. Does that make sense? Good, awesome. Okay, so go ahead and change that the way you wanted to. Okay, good. So now let's think about this a little bit. Let's step back and just look at the assignment that I gave you. I said, I want a function. And by the way, I want a single function. So on line 14, put a single function that gets the square root of something, then squares it, and returns the answer. So to be very precise, if it took in, for example, the number 9, it would get the square root of that, which is what?
3.
Good. And then it would square the number 3, which is what?
9.
And then it would return 9. That's a function I want you to build.
Okay.
One single function. And you can get any help you want.
So I know that I'm gonna need somehow to pass all of that. Something like that.
Tell me your thought process. Think out loud here for me.
Yeah. Can you hear? No, I'm not on mute. Okay. So I know at the very end I want to return something like square root times square root in order to square it.
Good. Now, before you go further, you've got a variable called square root on line 22, right?
Mhm.
Aren't you already using that exact word somewhere else?
Yes, here.
Yeah. So it's a function. You can't now you use that same name to be a variable.
Okay. Let's do just root.
Awesome.
So let's root equal. But I'm gonna do the same thing that I was doing before, so it's not gonna work.
Well, let's look at the function square root right now, the way it exists right now. You ready?
How can I assign the result?
Don't change anything. Don't change anything.
No,
Make
no.
that go back the way it was. We're going to start to think like a computer. Okay. And by the way, there's every single thing one of you does here in trying to work your way through this, every single line of code you write, every character is a learning opportunity. So we're just going to take our time through here. Let's approach what's happening inside the function called square root, the one that you're declaring on line 18. Let's think about it from a computer's point of view. It's going to do things in one step at a time in an exact order, because that's how computers work. When we first get inside that function and we're actually executing instructions, what's the first line of code inside the function? Inside the curly brackets.
That one.
Good. What does that line do?
It computes the square root of the number of the
Good.
parameters, and
then what?
return the get out of the store somewhere that number and get out of the function.
Good. So will we ever execute lines 21 and 23?
No.
Good. So you were saying earlier.
Oh, I see. No, because I can't assign a function to a variable.
What do you mean?
That's
You're
what
not,
you said.
you're not assigning a function to a variable. You're assigning the result of calling a function. Let's look at 19 very carefully. You're making a variable called root. That's the first part. It's called declaring a variable, right?
Mhm.
And now you need to assign it a value. The value will be the result of calling the square root function. You're not assigning the variable called root to be a function. You're assigning the value of the variable called root to be the result of executing a function. You're executing the built-in square root function. Whatever the answer is to running the square root function, whatever value it returns, you use that value and assign it to the variable called root.
Mhm.
Do you understand that? Is that all right?
Yeah.
Okay, good. All right, good. So on line 19, you now have the square root of whatever got passed in.
Mhm.
And then you return root times root. Does this look like it should work?
So let me think. So if I put a 9, it will tell me that root equal 3, and then I return 3 by 3, and it's gonna return, oh, it's gonna give me 9. I just need, I won't be able to access that if I don't assign it to a variable.
Won't be able to access what?
The result of the root times root.
Where do you need to access it? Outside of the function? I think I know where you're going with this. Let's follow this along. Let's change things a little bit inside your function and make a variable inside there that you'll make equal to root times root. Is that what you were thinking?
Yes. So I would have, for example, let result equal root times root, and then return. Yeah, but that's like what happens earlier. With
No, it
JSON.
worked.
I feel that
It
yeah,
worked.
but I feel I have too many
What?
too many things here.
Too many variables?
Yeah.
You do, but it's all right. It's all right. Good. I want to point something out. Ellen, you did exactly what Jason did, which is awesome. You built a function that gets the job done. It works. Yes, we're going to find some great ways to refine it or use it for some other educational means, but you did it. You did it. Now, I want to ask you about one thing you were saying in the middle of that. And by the way, I really appreciate you thinking out loud as you're going through this. At a certain point, right before you changed lines 18 and 19, you said, basically, I won't be able to access it.
Mm-hmm.
And now you made a variable called result. Where would you need to access that?
I was thinking if I put return root by root, it will give me the 9, but I guess I didn't realize that this function, this return is still part of the function.
Yeah.
So I thought it will need
A variable.
something to call it. Yeah.
Yeah, a variable to hold it in, right?
Mhm.
Yeah, this is excellent. You guys are doing great. This is excellent. Like, this is actually what it's all about. It's these simple building blocks. So I'm going to ask you to do something kind of interesting here. I want you to look at line 18. You already have a function that'll calculate this, calculate the square of a number, don't you? Not the square root. You have a function that'll calculate the square of something. We built it.
Yeah.
It's on line 9. So I want you to call the squared number function. No, stop for a second. Not that line. Line 17 calculates the square root. And it's golden. It's perfect.
Yeah. Yeah. Mhm.
Line 18, I want you to call that other function to get your answer. What do you pass in? Yes. And look at the answer. It still works. On line 21, change it to like 25. It works.
Yeah.
Put something else in there that's not going to make the math really easy. Give me a 20. I want to see what happens. Look at that.
Yeah.
This is good. Good. Now, I'd like everybody to pay attention to this next thing. We're talking about where the path of execution is. I'm going to lead you through it one tiny step at a time. Line 5. We're on the main path of execution and we log something to the console. Line 7. We go from the main path of execution down inside simple function. And now the path of execution is on line 2. And then we return the 5 and we jump back to line 7. Line 7. Path of execution is back in the main path, right on this file. Then line 9 doesn't do anything. We're just declaring a function. Line 12, path of execution goes from the main path down inside squared number, goes down to line 10. And then when it's done with line 10, comes back to line 12. Anybody not following so far? Good. Now line 16 through 19 doesn't do anything because we're just declaring a function. Line 21 is what I want to focus on. We're calling the square root function. And so suddenly we're on line 17 inside the square root function. And then when we were done with line 17, we go to 18. But now on line 18, we call yet another function called squared number. And so the path of execution moves from inside the square root function where we were, and the path of execution jumps down into the squared number function. And now we're on line 10. When we complete line 10, we come back to the path of execution being inside the square root function. And then we're now complete with line 18, and we jump back to the main path of execution on line 21. So we went down 2 levels in terms of the path of execution. Did anybody not follow that? Okay, cool. All right.
When you mention path of execution, are you like kind of talking about the scope without talking about the scope?
Yes, and the reason I don't use the word scope is because it means something very precise in each language. A much more technical description would be the precise focus of the computer's instruction execution machinery. There's several different terminologies for it, depending upon what compiler you're using or your interpreter. It's which set of instructions are being executed. The main path is the top level ones inside the file we're looking at. That's the main path of execution. But there's a path of execution inside every function. Now, the function on line 9 called squared number only has one instruction in it, line 10. But that is a path of execution. I don't care if there's only one instruction, that is a path of execution. Because believe me, you can have much more complex functions that have control and branching statements and all kinds of stuff inside them. They have their own path of execution. This path of execution happens to be only one step long. Line 16, this function called square root. That path of execution is a little more complex. It's got 2 whole steps, line 17 and line 18, but it's still a path of execution. Does that clarify that, Ellen?
Yeah.
Okay, good. As we build functions that have, several steps in them, it becomes a little more visible what we're talking about. Because you can see yourself staying inside one function for quite a while and then popping back where you came from. All right. Go ahead and stop sharing. Oh, that's excellent. Here's what I want you to do, okay? Because we've got 5 minutes left before we end off for the night. Sudesh, how's your week look for catching up?
I got the audit on the Monday, but I got next couple of days, some hours, so I will catch up.
Okay, good.
Yeah.
If you can at least get up to this section on functions.
Yeah.
Okay, that'll be very, very helpful.
Yeah.
The rest of you, if any part of what we just built was confusing for you and you weren't sure what was going on, then I want you to make sure that even if we need to reread it, spend time on that function part. And I want you to build no less than 10 of your own extremely simple functions like we built now. And I mean simple functions that will add 2 numbers, functions that will do subtraction, a function that will take a first name and a last name and put them together with a space between them. Dead stupid simple functions. I'm much less concerned with building some complex stuff than just having you over and over and over again build functions and then write the code to call them. Build a function and call the function. Build a function, call a function. I want you to do that over and over and over again for at least 10 functions. And make sure that at least 3 times you build a function that will then call another function, just like Ellen just demonstrated. So that's your homework for the week. Make sure you're at least through the function section. Write 10 functions. It includes calling them. I want this all to be in one file. And at least 3 of those should go 2 levels deep. And they should call another one of the functions you created. Any questions on that assignment? Okay, now in this one in particular, I've got really good availability now. Okay, I have a lot of things off my plate. If you're stuck, and I mean if you're stuck for more than 10 minutes, just ping me on Discord. It's super important. And I really mean this. The skills and knowledge that you're building right now around path of execution and functions are amongst the most valuable things you will ever learn in JavaScript. Almost every complexity thing that kicks people's ass, confusion, and frankly, people abandoning their study of JavaScript almost always comes down to a misunderstanding or confusion around these central core concepts of functions. We could spend more time on this than anything, and it would be time well spent. Okay, good. That's what I have. Anybody have questions or comments?
No.
Okay. I super appreciate all of you for being willing to share on screen and struggle through that and work through it. You all did a great job on it. I tried to do as good a job as I could with each of you shared in leading you through the understanding of it. If any part of it still after this is like, I'm not quite sure what the hell you were talking about, Eric, ping me privately and we'll go through it, okay? Okay, cool. So 10 functions, 3 of them go at least 2 levels deep and call another function that you created. And just put them out on GitHub and send me a link to the GitHub repo, okay? Cool. Awesome. Anybody have any?
Question.
Yeah, go ahead.
Do we have class tomorrow?
No, we're not gonna be able to do, we're gonna do Monday, Wednesday, Monday, Wednesday, Monday, Wednesday, but I can't do it tomorrow. So our next class will be Monday. That's why I want to give you that assignment. And by the way, if everybody gets done really quickly, I've got more I'll give you, but I want you to get those 10 done and I want to see the work from each of you before I assign you more, okay? So please try to get it done in the next couple of days. That way I can see how you're doing on each of them and then assign you more to build those skills. Cool. Anything else?
Do we need to send the file to you? Email?
No. Do you know how to do it? Make a GitHub repo, Sudesh?
I need to go through that. I will
Don't worry. Then
find
just send me the file. It's fine.
Okay.
Now, if you email that file as a JavaScript file, it'll get rejected. So
Okay.
change it to a .txt file, and I'll
Yes.
change it back to JavaScript.
Okay.
Okay, good. Anybody else or anything? All right, good. Awesome. It's good to see you all again. Thank you for working through that. Get those 10 functions to me as soon as possible, and I'll give you more. Otherwise, I'll see you next Monday.
All right, see you guys.
Wow.
Thank you.
Bye.